Right. Yes, from the introduction, we have already talked about what we are going to be talking, the trends going down the graph. So without wasting much of the time, let us just go into point number one. What is happening to the atomic and the ionic what? And the ionic radius. Yes, from previously, we have already discussed, but this one is an easy one. From earlier, we have already discussed what is happening. As we are going down the globe, we are saying that the number of electrons, they are increasing. Point number one, the number of electrons, they are increasing. And when the number of electrons have increased, it means the number of shells, the number of shells that are surrounding the nucleus, they are going to what? To increase. And when the number of shells have increased, it means the size of the atom is also going to increase. And when the size of the atom has increased, it means the atomic and the ionic radius is going to what? It's going to increase. Automatically, the size increases, it means the radius is going to what? It's going to increase. Yes, moving on to point number two. We are talking about the strength of the bond. We are talking about the strength of the bond. Yes, back in the days, we were performing covalent bonding. Yes, some people are still shocked what was being done in covalent bonding. Ionic bonding was also performed. Metallic bonding was also performed. Covalent bonding was between atoms or was between non-metals. Ionic bonding was between non-metal and metal. Metallic bonding was between metal. And after this bonding have been done, it was in our best interest to do a careful analysis on the strength of the bond, as we have weak bonds and we have got also a strong bond. So we want to see what will be happening to the strength of the bond as we will be going down the group for all of the covalent bonding, the ionic bonding, and the metallic what? And the metallic bonding. So we are going to what? To first consider the covalent bonding. Covalent bonding, what do we really what is really used to measure the strength of the covalent bond? We are going to use what is known as bond energy. Bond energy. Bond energy is the one that is used to measure the strength of what? Of the covalent bond. The strength of the covalent bond is measured using bond energy. So what we are going to focus is what really happens to the bond energy as we will be going down the what? Down the group. So as we will be going down the group, we are saying that the atoms, they are increasing in size, right? And when the atoms are increasing in size, it means the bond length is going to be what? The bond length is going to increase. And when the bond length is increased, we know that the bond length is got, we know that the bond length has an inverse relationship to bond energy. So we are saying bond length has got an inverse relationship to bond energy. So what does this mean? What does this mean? This means that the bond length, as we increase the bond length, so okay, so we can just write this. We can just write it as this. We can just say this one, bond energy to bond length. Yes, it's still one and the same one, one and the same thing, one and the same thing, one and the same thing. So we are saying that as the bond length increases, the bond energy is going to what? It's going to decrease. The bond energy is going to decrease. So from here, you can see that as we are going down the group, the atomic or the ionic radius is going to increase. And when the atomic and the ionic radius is going to increase, it means the bond length is also going to increase. And when the bond length is increased, it means the bond energy is going to decrease. And when the bond energy is decreased, it means the strength of covalent bonds, as we are going down the group, they are going to be be weakening. They are going to be weakening. So it means that the bonds that are formed by elements down the group, when they are non-metals, they have got weak bonds. They have got weak what? They have got weak bonds. They have got weak bonds. Weak bonds. Okay, I wanted to do an example. But let us just what? Let us just move. Okay, we want to consider what? We want to consider ionic bonds. We want to consider this one, ionic bonds. Now, what is used to measure the strength of ionic bonds? We have got what is known as lattice energy. We have got what is known as lattice energy. Lattice energy is given by the formula of Q positive of Q charge minus over R positive plus R minus. Yes, what am I saying? That lattice energy is the product of the charges of the elements that are being involved in the bonding of the total radius of each element. So we just go back again. We are saying as we go down the group, the atomic and ionic radius, they are increasing. And you can see that this lattice energy has got an inverse relationship to the what? To the radius. So as we go down the group, there are going to be an increase in the what? In the radius, and when the radius increases, it means the lattice energy decreases. Therefore, the strength of metallic balls they decrease as we go down the group, and we are going to be moving to what? To the metallic bonds. What happens to the strength of metallic bonds? So we are saying that as we are going down the group, the size of the ions are increasing as we go down the group, which implies that the charge density of metal cushions, this one, the charge density of metal cushions will also be decreasing. And when the charge density of metal cushions decreases, it is going to result in weak forces of attraction between the metal cushions and the sea of delocalized electrons. They are going to be weak forces, and when there are weak forces between the metal cushions and the sea of delocalized electrons, it means that weak metallic bonds. Yes. So for now we are going to end. So we have discussed this one and this one. In our next video, we are going to be discussing this one, and maybe this one, and maybe that one, and maybe this one. We are going to see.